Hey everybody, it's Rob Essler again. We're going to do our third tutorial. Today we're going to talk about classes, conditionals, loops, and arrays using the Pd4P3 library and processing. And we're going to learn how to program using audio and music. So today we're going to start in an empty sketch and we're going to go to the oscillators example. And we're going to take all this code, copy it, paste it, and we'll close that. And this is really simple sketch. You've probably seen it before in one of these tutorials. So first thing we're going to do is learn how to make a new class. And the way we're gonna do this is we're going to create a synthesizer and basically use this part here, which this is our really just our Pd4P3 code. Right, and up top is just going to make a really bold comment here. This is our processing code up here. So I'm going to make a multi-line comment and say this is processing code. And if you're still not sure what I mean by that, what I mean by processing code is this is code that does the graphical side of things. And that's kind of processing's thing. So Pd4P3 is audio that will work in processing. Okay? So we're going to save our sketch to our desktop. We're just going to call this, we'll call it additive synth, because that's what we're going to kind of go through today. And we're going to get rid of that. And we're going to get rid of that. For now, we'll just initialize it to 0, and we don't need to free any memory because we have no memory. Nothing to free. So we are going to create a new tab and we'll just call it additive synth. Oh, yeah. Okay. Because I called the original tab additive synth. So let's just call this synth. It's trying to create two files with the same name, so that was dumb. All right, so to make a new class, you just use the word class. And since I like to keep my classes the same names as my tabs, so I'm going to just call it synth. And we're done. End of tutorial. No. So now we got to add members, and so both variable members, and we need to add methods to our class, so our class actually does something meaningful. So one of the members we're going to need is going to be a, we're going to need a perform method. So we're going to do public so that anyone using this class can access this method. And it's going to return a double, which is a floating point number. We're going to call it perform to keep it consistent with all the other Pd4P3 objects. And remember, this is a legacy name used in the old C code of Pure Data that we're keeping. And it's going to take a floating point input of frequency, since this is an additive synth. Okay, and it's going to not like that for a little bit, but it's only because we haven't returned anything to it yet. Then we're going to do a free method, and this is where we're going to free all of our data. So just like we do here, we're going to do it here as well. So it's actually going to, we'll see kind of how this all goes down, but all right, let's do some members here. Let's make some oscillators, since this is a additive synthesizer. So we're going to do oscillator 1 equals new oscillator. So actually remember that these are oscillators, a class that we're turning into an object called oscillator 1. let's make another oscillator. Oscillator 2. Okay, and before you take another breath, free those oscillators. So recall that since Pd4P3 is running C++ code in the background, C++ code creates memory, and it doesn't know to release the memory until you tell it to, which is one of the great things about Java, because Java just does that for you. But since C++ does not, you have to tell it to do that. At least the way we have to run things now. There's ways in C++ that you can get around that, but right, not using Java, at least not easily. So here is our free. This is going to be our perform. So now we're just going to do, I'm just going to make a variable called out, which is a floating point, and then return out. And so now our synthesizer does nothing, but it gets rid of that error. But we're just going to set out to our oscillator summation, or add the oscillators together. So if you know how to add, this should be easy. So we do oscillator.perform and give it the frequency. And since we're dealing with multiple frequencies, we actually, if we just did this, freak times, we'll just do it the second harmonic. So if we just did this, it might sound okay. It also could distort. So we want to, when we sum anything together, it just makes, just think about it, where our audio is looking for a number between 1 and -1. That's all that audio is. It's some sort of number between there. And if you start adding in multiple ones, the audio renderer doesn't care if you're trying to get a 2 or 3. It just basically puts it at 1. So you can't go above 1, you can't go below -1. And so if you start adding multiple numbers together that are larger than 1, it's just going to distort it, going to basically set it straight to 1 or clip it. And that's when you're going to get distortions. So you want to make sure that your numbers, the amplitude of all of your oscillators, are summed and then scaled in some way in volume. And by scaling things in volume, you just multiply it by a number less than 1. So I'm going to scale this one to 0.7. I'm going to put that in parentheses just to make sure I get the order of events correct, so that it multiplies this one first and then this one second and adds them together. And I'm going to scale this one by 0.3. So now this is, think of this as 70% of full volume. This is 30% of full volume. And now that adds up to 100%. And it shouldn't clip, ever. Famous last words, right? So this should work fine. Okay, so now we go over to our algorithm and we're going to create a new synth. So synth, and I'm just going to call it lowercase s synth. Kind of a standard coding style is objects are uppercase and variables are lowercase. So synth equals new synth. Perfect. Now we should just be able to do synth.perform get frequency. And we're going to free our synth. It's not static, so we can just do synth.free. If you don't know what I just said, don't worry about it. You just got to do that. So we're actually going to call in free, since remember this is called here in the back end of our code. So we always have to have a free method whenever we do our Pd4P3 class, right? Which always has to extend. Okay. So one thing that we didn't do here is we didn't write that extends. Right? So extends means it inherits all of the public members or protected members and other variable members of your class. So it's a way of making your class do more without having to write any more code. And it's one of the more powerful features of object-oriented coding, so that you can write just a little bit of code and it can do a lot of stuff all at once. Okay, so that's why this one extends and this one doesn't. But if we wanted to, we could extend the PD master class, which then gives us access to more variables, well, mainly more function methods that we can use to alter data or access other parts of our code base. Okay, so but I don't need that, so I'm just not gonna make the compiler do more than it needs to, since we're trying to do high performance audio. Okay, so what were we doing? I think that's good. Get frequency, set frequency. So everything stays the same up here. We're just using the mouse to map our frequency and setting it using this setter here. And that's not necessary. There's another, yeah, that looks good. I think that's gonna work. Let's try it. All right, that did work. So let's make it now a little more interesting. Okay, so we've created our class and we've followed the same sort of style, having the perform method and the free, right? So that when we call it like we have with any other Pd4P3 method, we use the perform. That gets our audio. We send that audio to our output left and right, and that goes to our speakers, or default speakers, or default headphones, whatever you've got set in your system. But let's say though it's just running constantly. So let's say we only want it to, we want to hear it when we press the mouse. Okay, so we're going to need a couple of new things. We're going to actually need to do something called a conditional, which is what's called an if statement. And so an if statement is basically saying if some sort of condition is true, then do something. So the first thing we're going to need is we're going to create a new type of variable called a Boolean. And I'm going to call it bang to go along with the PD style. A bang in PD is basically a signal to PD saying do something, do it, like a button. So it actually is shaped like a button, but underneath everything it's just basically a conditional that says do it, yes, true. So Booleans in Java though can either be true or false. In fact, just using the word true and false indicates a Boolean, but we're going to actually create a variable called Boolean and set it to false. And then we're going to create a getter and setter for that Boolean so that we can access it on the GUI side. So we're going to do a synchronized void set bang, and we give it a Boolean argument, and that's going to set our Boolean bang, and then we'll do the same to get it. Synchronized Boolean, so it's going to return a Boolean. So if you're not familiar with Booleans, you use them all the time. Your light switch is a Boolean. Your every button you've ever pressed is a Boolean. Most decisions you have to make in life are true or false, right? So it's a really easy concept to understand, and it's just one bit. It's a 0 or 1. So that's really easy. But if you're coming from PD land, you know that bang is a one-way Boolean. It's just true, and then it immediately turns off, immediately becomes false. All right, so then, so we're going to use that Boolean to basically turn on our synth and then turn it off, just like a bang in pure data. So we're going to multiply our synth output by something called an envelope. So I'm just going to call that ENV, short for envelope. So that's just going to give it a shape. So you remember anytime we multiply an audio signal by a number, it changes its volume. So if the volume is changed to 0, you will hear nothing. So right now we'll hear nothing if we played the sketch. So instead, what we're going to do is create a conditional down here. So anytime anything inside of the if statement, so you see how we have, this is what an if statement looks like. I'm just going to write the word true in there. So basically, this is, remember our braces always indicate blocks of code. So this is kind of contained within the if statement. So if something, and this is going to test whether that condition is true or not. So we're just going to say get bang. And if it's been set to true, which we're going to set up in processing in a second, anytime the mouse has been pressed. So if that is true, do this line of code. Okay, so what we're going to do is we're going to create a ramp up to our envelope, and that requires a PD object called line, or Pd4P3 object called line. So new line, and if you've used PD before, you probably know this convention. Make sure you free it before you move on so you don't forget. Which is to basically change a number over time. And this is going to create a very simple envelope. So we're going to do line.perform, and when you look up the API, you'll see line takes two numbers. One is where it's going to, so it starts at 0, and it's going to go to 1. That's going to be full volume. And then the next number is time, so how long, and it's in milliseconds. So let's just say 15 milliseconds to give it a really short ramp. And then the other half of a conditional or an if statement is the else. So basically, if this is true, do this. Otherwise, if it's not true, do something else. And what we're going to do is set that line back to 0. So it's going to go up and down, and we're going to give it a little bit of a decay. So this is like an ADSR, but without the D or the S. So it's an AR. It's an envelope. Attack, decay, sustain, release. It's just the attack and the release. So, and then we got to give it one more conditional, and that is if we've reached our max envelope. So if our envelope is equal to 1, and notice this little bit here. Equal is, there's two different types. So when we use it up here, like float, oscillator, like when we set variables, we're setting the variable to this number. So it isn't, but if we want to compare it using a conditional, we have to use the double equal sign. Because if we just did this, this is always true, and it's going to throw an error because, yeah, it doesn't even match what you're trying to do. But, so good thing that throws that error for you in case you do that wrong. But if you're trying to, if you did do that in another instance, like in C++, you can do that. It's always true. Anytime you set a variable to something, it's true. So that will always throw, it will give you bad errors. So don't get into that habit. So double equals is the conditional. It's if the envelope is equal to 1, right? So that means after this line of code is completed and got to 1, then what we're going to do is set our bang to false. Okay, so now it will do this line, and we should only hear it when the mouse is clicked. Okay? All right, so now let's do our little mouse clicking up in the processing side. So we're going to use actually a method called mouse pressed. So in processing, this is something that comes with the package, which is a really nice feature, that it does all this for you. You don't have to detect it yourself. And it turns nice and blue, so that tells you this is something that is part of the processing package. Perfect. So now we're going to do music.setBang true. So we're going to set our bang true, right? It starts out false. Over in processing, send it to PD for P3, and then when it gets it, it's going to say, okay, that's true now. Go ahead and perform this line. Okay, and it's going to stay true until it's finished, and then it will hit this block of code, and now this will be true here, and now you set the bang to false, and now it's going to go back down to 0. And then it will multiply our synth output by our envelope, and you'll hear it only for that time period. Here we go, cross your fingers. Perfect. And the frequency left to right is still preserved. All right. That's looking good. Now, let's add a third concept. Third and fourth concept, actually. This is where the fun begins. So we're going to actually now we're trying to make an additive synth, and if you're not aware of what that is, it's just basically oscillators all adding up together. And you're setting each oscillator to a specific frequency and a specific amplitude. So trying to mimic like the more natural nuances of a sound based on every single sine wave that exists within that sound. And it gets pretty processor intensive, so you don't want to do this too much. But you can make really complex sound this way, but you have to control a lot of moving parts. So you take the goose with the gander, or whatever that is. All right. We're going to get rid of some code here. And so we're going to create what's called an array. And notice how right now we haven't set it to anything. So it's just an array of oscillators, but they have no, they don't exist in memory. In fact, if you try to do anything with them, it'll just throw an error. Okay, so we're just going to say this is OSC is going to represent an array of oscillators, and an array in code is basically a group of things that are of the same type. So if you want to have, like, for example, like in music, you're trying to make a scale. Right? A scale would be an array of numbers that represents the notes in the scale. Okay, it's used pretty often, and in our case, we're going to use it to make an array of oscillators so that we can create our oscillator bank or group and then set it to whatever we want and create more complex sounds that way. Okay, so in order to do that, we're going to need something that will actually initialize our array. So we're going to do set a new, should be public. Why did I not do that? Okay, so we're going to do public void set oscillators, and we're going to give it an argument of size, so the number of oscillators. And this is where we're going to learn yet another concept for the day, which is loops. And I'm going to just show you a really simple loop called a for loop. And a for loop actually has conditionals, like our if statement had, inside of it. Okay, so there's a couple of types of loops, and the for loop is the most common one, I think, and the second one is probably the while loop. But the for loop really just gives you a conditional, and it keeps doing this block of code until the conditional is met. So it's kind of like putting an if statement inside of a loop. So we're going to just create a variable inside of our loop here called I. This is probably the most common variable type to use, is an integer and calling it I, short for int, right? Integer. And then we're going to do I, while I is less than the size, so that corresponds to here. Actually, you know what? Let's do one more thing. Yeah, we don't need this bit yet. We're actually going to set our oscillator size here. So remember how we do that on the other side where we would set it to a new? We're actually going to say oscillator equals new, spell it right, new oscillator, and then we're going to say size. Okay. Then we're going to compare it to the length of our oscillator, which is the same number as size. Should be. It better be. Otherwise, we have some major problems. Okay. So this is the size of our array, right? And so now we've put this into our memory, and then we compare it to the length. And the only reason I bring this up and don't just put size here, because this would work exactly the same. But the reason why I'm telling you this is that now length is a member of the parent of all classes, right? So this is something that you get anytime you make an array, which is something that's automatically inherited from the superclass that you don't even really realize is out there. So this is the great thing about object-oriented programming, is that you get this thing that will actually calculate how big this is, how many members are there for you without having to do anything, because it just automatically inherits that without even asking to inherit it. So there's a lot of member functions and members that exist in Java and in C++, that give you access to these things when you don't even have to explicitly ask for them. And sometimes, like, that's good, and sometimes it's annoying, but you know, I generally think it's worth the hassle. Okay, and so for each oscillator, right, we access it by doing these brackets, and you give it a number, and that number is going to correspond to our number I, or int I here. So it's going to go from 0 to the end of the length. And for each one, it's going to create a new oscillator. So it's no different than the way we have done objects before, like here. It's just we're doing it many times and storing it inside of a variable. So this is a way of making multiple objects in just one object call. And then you just give it a number, or which member of the array are you trying to access? And it's going to be start at 0, because that's how computers count. They start at 0 and they go until the size, and that gives you the size of the array. So as long as I is less than the size, right? So it's going to actually, the number here would be 1 less than that. So if our size is 4, it's going to go 0, 1, 2, 3. But if you count 0, 1, 2, 3, that's 4 numbers. So that means that there's 4 oscillators inside of our array. Okay, so we're going to make them here. And then how do we free them? Well, it's just as easy as doing the same thing as we normally do, just putting it inside of a for loop. And so we're going to keep that for loop. And now that it should know that the oscillator should know the size, we could do a check real quick to make sure that we didn't forget anything. So why don't we do a quick if. So if OSC is not equal to, that's what that little exclamation point means, not equal. 2 equals means is equal, and if it's not equal to, what's called null. And null just means there's nothing inside. Right? Sometimes isn't that how we all feel? We feel a little null. All right, that didn't do what I wanted. Okay. There's got to be a shortcut for this in processing. All right, so if OSC is not null, so that basically means if we forgot to do this function, which when I was testing this, I forgot to do it and it threw the error. Now we're just going to do it like we always have, oscillator.free, but then we're going to put OSC and then in brackets I. So each time it's going to go through and free the object in memory, one after another. Okay, and this is just a little check. This just checks to make sure you set the oscillators. Okay, so make sure we're going to set them here, we put them into memory, and then we take them out of memory here. So now we can do the fun stuff. So I'm actually going to copy this and put it here. Get rid of that. So once again, we're going to check if our oscillators were set before we start making audio. And so what we're going to do is we're going to add each oscillator together and then get the summation and send it out. So you won't actually hear this happening. It's going to happen all at once. And then it's going to go to the output of the function here, right? That returns a double, so it's going to go out. And so it's going to actually be the sum of all the oscillators. So we're going to do a little special shortcut in coding, which is the plus equal. So what this means is that as we loop through each oscillator, which, let's do that real quick. Oscillator. So the way we do that is we just use the same syntax, OSC bracket I, that we've been doing each time, right? This is now iterating through each member of the array. And it still has its members. So we're going to do perform frequency. Right, now what this would do, it was add up every single oscillator that you set. So you give it the size. So if you had 10 oscillators, it's going to create 10 oscillators, add them all together at the same frequency. And that's just going to sound horrible. It's going to distort like crazy. So instead, we're going to actually make a little bit of, we're going to make harmonics. So we're going to actually just use the number of the harmonic by using the number of our iterator and just add 1 to it. So what this does now is it's going to multiply our frequency by I plus 1. So that means that if you have 7 oscillators, it's going to, and your first frequency is 100, each oscillator is going to be 100, 200, 300, 400, 500, blah, 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 and add that all together. But as you know before, right, we're dealing with additive synth. We also have to multiply it by scalar, something to bring the amplitude down. And usually the way additive synths work is that the lowest frequency is the loudest and the highest frequency is the softest. So we're going to multiply that by a fun little fraction. So for every single time we iterate through, it's going to take, just like we did with the frequency, basically make it to a harmonic. We're going to do the same thing but divide it by 1, so, or 1 divided by it. Okay, so now it's going to, the first one will be 0, right? It starts in 0, and so 0 plus 1 is 1, and 1 divided by 1 is 1. Okay, no problems there. So then the next one is 1, so 1 plus 1 is 2, 1 divided by 2 is 0.5. So the second oscillator is now half. And then the third one is going to be a third, and then a quarter, and then a fifth, etc. So it's, each one's going to get quieter and quieter, and that way you're not going to have just this loud, blaring, distorted oscillator, but it's also going to have this tapered amplitude, which is exactly what happens with most musical sounds, is that the higher frequencies are quieter, the lower frequencies are louder. And that should do it. It doesn't like something because I don't have enough braces. Okay. So now you see we've got braces and braces. So we have this if statement. Check if we actually did the set. So make sure that we put some oscillators in memory. And if not, it's just going to sound like nothing. Then we put our loop inside of that, and we're going to loop through each oscillator, multiply it, right, by our iterator. Now you could ask, why don't you just do 1, start at 1 here? And the problem would be that 1 is actually the second member of an array. So you would have to, that would be kind of weird. You'd have one member that never gets accessed ever. So we have to start at 0, and we have to just add the 1 here. And it's a little bit annoying, but it's just something, that's just the way computers work. And here it's really important that we do that, because if you try to divide by 0, you get like missiles get launched in North Korea or something like that. So you got to be really careful. All right, now let's see if I've forgotten anything. No, it all looks fine. Let's go back here. Synth perform get freak. All right, let's see if that works. Gotta just try it. It's not going to work. It's going to give me a 0, nothing. Because what didn't we do? Just like I said, we didn't set the frequency. I'm sorry, we didn't set the oscillators. We never did this here. So we got to find a place to do that, and we only have to do it once. So we're going to create our own method to do that, and this one does not have to be synchronized. So we're just going to basically we're going to just do set synth. And since this is a member of synth, right, we're going to do synth.set oscillators. And it takes a number of oscillators. So let's just start with 5. And then where does this get called, though? Well, we have to call that in processing because we want to actually do it first thing. So remember this setup method in processing? This is the first thing that gets executed when you run your program. So since we make our music class here, which is this here, right? All this gets created up in processing. We're just going to write music dot set synth. And you could also, if you wanted to, make it have a number here. So we could do like this. And it would pass that number down to here. It really doesn't matter where you put that. So you can do it there or down here. So this is what we'll do. So we're just going to put our number of oscillators there for now. Set synth, set 5 oscillators. Call that here. So we're going to set up our synthesizer. And you could do other things too here under set synth. You could, have some other things that need to happen, like I don't know, change your attack and decay times or whatever. There's a lot you could just do right here. So it only gets called once. And let's try it now. It is mildly distorted. So we would need a slightly better algorithm. So let's just do this, just 0.8, just to bring it down a hair each time, so it's not going to be super loud. We'll just see if that makes any difference. All right, so we did it, everybody. We learned class, right? We made a class. It's called synth. Made an array of oscillators, right? Created a conditional, many conditionals today, conditional statements in order to create an envelope when we click the mouse. And we created loops, specifically the for loop, which is the master of all loops. So let's actually add one more element to it that's a little bit more fun. And we're going to have it do something with like drawing a line in processing, just to add some cool graphics. So we're just going to do a Boolean here on the processing side, and we'll just call it draw line and make it false. And we need one more method so that when we lift up the mouse or release it, we can set that to false. All right, so when our mouse is pressed, draw line equals true. And when our mouse is released, draw line equals false. So remember, mouse pressed and mouse released, these are come with the processing package, and they are under input, mouse pressed, mouse released, mouse dragged, mouse clicked. Anything with the parentheses is a function or a method. Anything without is a variable. So those are 2 different ways you can access the mouse without having to do anything other than just having processing. So that's kind of a cool little feature of this software. Okay, so in our draw function, we're just going to say if draw line. So if, once again, is our conditional. If that is true, right, it's true if the mouse is pressed and false if it's released. So anytime we press the mouse, it will pick it up here and do whatever is inside of here and then stop doing it when it's false. And we're just going to do black line. So stroke 0, that number 0 is computer code for black. And line. So line draws a line, and you need to tell it where you want to draw the line and where you want to put the line. So we're just going to draw the line at the mouse X and Y point, and put the line at the mouse X and Y point. So it's just like your standard draw functionality. And now the moment of truth. Cool, now we have a drawing program with a sound, right? And you could change it so that it stays, the sound stays on until you release, right, the mouse. But I'm going to draw Pd4P3. There we go. That's what that sounds like. You could also, right, you could music set bang, you could have you could put that here and set bang to false when the mouse is released, and then it would allegedly keep it on until we, set bang, until we turn it off. Let's try it live. Untested code here. We'd have to get rid of this for now. All right, this is it, live on YouTube. Fun. There you go. That's code in the wild. What are we going to do in the future? Well, I think what we're going to do is just have short little videos about simple concepts now that we've learned a lot of the basic stuff. And we'll review a lot of this as we do new things. Well, let's talk about music and sound now and have some fun. So that's the third of our tutorials. I appreciate you being here, and I'll see you next time.